Alright, this video is going to be about solving quadratic equations using square roots. And the first thing we want to remember about solving quadratic equations is they're very tricky. They kind of have a few things that we have to worry about. They're not like linear equations where everything's sort of just move everything over to one side, get the variable isolated. That's actually what the square roots method will be much more about. If you remember, solving quadratic equations like the ones here on the screen, we have to be a little bit careful, such as over here where we have this middle term. If we try to just solve normally and subtract 35 and do kind of other things, it doesn't really work. So instead, we learned about the method of factoring already. So we would say, okay, what multiplied to 35? Well, hey, -5 and -7 would. That also added up to that middle term, right? That added to that -12. And again, -5 and -7 seem to work really well. So then in that case, well, what would make x minus 5 into 0? Well, 5 would. And what would make x minus 7 into 0? Well, positive 7. And we get our two answers. And the same thing goes over here. We'd set ourselves equal to 0 first. But then we would say, okay, multiplies to 25, adds to 10. Looks like 5 and 5. And since both of those, well, what makes x plus 5 equal to 0? I would say -5. But both of them have the same answer. Basically, it just comes out to -5. And then finally, down here at the bottom, it's that difference of squares, right? We've got a 25, so it makes me think 5 and 5 again. But again, I don't want a middle term like I had that 10x up here. We have 0 as a middle term, 0 as a b value, but we want a -25. So remember, we're going to say plus and minus 5. So we'll get a -5 here and a positive 5 there, and we'll get our answers. Now, those were great methods of solving. Factoring doesn't have any problems there. That's not a bad thing. But I'm thinking we could do this just a little more quickly. So what I'm going to do right here is I'm going to go ahead and grab these two equations. I'm going to delete them here. We'll leave the answers, so we'll show you we're going to end up with the same answer. I'm going to do the same thing down here at the bottom. Now these two work really, really well because what we can do is instead of factoring, what if we just went ahead and solved? Notice down here in the bottom there's no middle term. So we could actually just add 25 to the other side. And then in order to get rid of a squared power, hopefully you know that the inverse of a square, right? So x squared equals 25. Well, that just means that the square root of 25 must have been x. So again, we could say that this was a 5 here. We'll just scribble over it there. 5 squared would have been 25. Well, the square root of 25 is 5. So in that case, if we take a square root on both sides, right, we'll end up getting our 5 down here. Now the question is, how do we end up with that other answer? And what we have to remember is any number squared would equal a positive number. But since we're going backwards, isn't -5 squared also 25? Anytime that we take the square root on both sides of an equation, this side will just become x. But what's going to happen over here is we're going to say plus or minus the square root of 25. So the square root of 25 becomes 5 on the positive value, and the square root of 25 becomes 5, but wait, we're going to attach a negative value to it. So that works out really, really well. Now this one up top is a little bit trickier, and that's just purely because of the fact that it would end up being up that perfect square, so I should have left that first equation up here. So this actually looks pretty good. Plus 25 here equals 0. Sorry for the handwriting there. But now that becomes x plus 5 quantity squared equals 0. And what we can do is, since the squared is on the outside, we can take a square root right there, and we'll end up with x plus 5, because squared and square root cancel each other out, is equal to, and now normally, like I said, we had to say plus or minus. Okay, we're going to say plus or minus over here, right? Well, I don't have to do that right here. Plus or minus 0 is still just 0, and therefore subtract your 5, and you're going to get x equals -5. The idea here is, again, we can just solve like we normally have to solve quadratic equations when b equals 0. Right? When b equals 0, when there's no middle term getting in our way up here, right? When we get rid of that middle term, all we have to do is isolate the x squared, and then we can undo that equation by taking a square root. Don't forget that plus or minus. We're going to get two separate answers. So let's try that down here on both of these equations. Go ahead and pause the video now and just think to yourself, how could I isolate x squared? And then what do I do after that? Try taking that square root and see if you can't go get those answers. Alright, so we've gone most of the way on both of these equations. In the first one, again, I added 48 to the other side, so now it's a positive 48 that we're equal to. Then I'm going to divide away the 3, which gave me x squared, right? The 3's cancel. Still leaves me with x squared, equal to 16. Remember, the idea here is we're getting rid of the last thing happening. If I'm thinking about my order of operations, normally powers come first, so notice it's the last thing I'm going to get rid of. Then we would have multiplied, then we would have subtracted. So the first thing to go is the subtraction, then the multiplying. Now we need to get rid of that squared. So again, we're going to take the square root, we're going to take the square root, and we're going to say plus or minus. So x will be equal to plus or minus the square root of 16 being 4, and we've got our two answers. And if you take those numbers and plug them back in, 4 squared is 16, times 3 minus 48, I guarantee you're going to get 0. Negative 4 squared is 16. Times 3 minus 48, you're going to get 0. Again, that squared cancels the negative, and right away we get two answers. So the same thing over here. Let's go ahead and take the square root. Take the square root. Don't forget to say plus or minus there. So this is going to be x equals plus or minus. Now on this one, because root 5 is not a pretty number, root 5 is an irrational number. It's got an infinite decimal. We don't really want to round it off. Let's go ahead and just leave it as an exact value. We're just going to say plus or minus root 5 there. And we'll just leave it be. Let's look at a couple more examples here and see what else we can do. So what do we do if things don't quite seem perfect? If we start to solve these equations down here, notice 5x squared again is equal to, we're going to subtract that 5, call it a 15. And then, kind of like the one we just did, I'm going to divide by 5. X squared equals 3. But now, if I take that square root, don't forget the plus or minus, well, the problem is the square root of x squared is x, but the square root of 3 is not a number I'm familiar with. But notice the directions this time. Round to the nearest hundredth only if needed. Well, in that case, they're telling us, well, it's okay to round. It's okay to find an approximate decimal. So what we need to do, I'll get my calculator out real quick here, is go ahead and find what is the square root of 3. And I may as well point it out for you on your calculator, what you're going to do. And let's go ahead and open up our calculator here. What you're going to do is go ahead and find the second button. Right, on most TI calculators, and really on most calculators, if you find that second button, that's where you're going to locate your squared terms here. So let me get rid of what's on the screen there. And what we're going to do is go look at our calculator. There's the x squared right here, and right above it is our square root. So I'm going to say the square root of 3, because that's what we needed to find. Enter. And it looks like it's about a 1.732. Now notice our directions. Round to the nearest hundredth. Well, remember, this is the tenths, then the hundredths. So I'm going to look one more step here. I'm going to look at that 2. 2 means I don't round up. So I'm thinking 1.73 looks pretty good. So the positive square root of 3 would have been positive 1.73. And the nice part is the negative square root of 3 is negative 1.73. So there are the two answers that we come up with. Now, just because a number doesn't come out perfectly cleanly doesn't mean we have to round. So let's be careful here. If I add that 80 to the other side and then I divide by 9, well, you'll notice on these two, 100 and 9 are both perfect squares. So when I go to take my square root, remember, we've got some rules that say if it's the square root of a fraction, much like exponents, much like having an exponent, I can apply that square root to both the top and the bottom. We actually have a rule that says the square root of a fraction is the square root of the top and bottom. It's the quotient property. So this just became plus or minus. The square root of 100 would have been 10, and the square root of 9 would have been 3. And we get our two answers. Now, again, go ahead and try these two. I will give you a hint for the second one. Do not FOIL. Do not FOIL. Think about how can you just undo the operations that are already present. All right, let's take a look at both of these problems. We're going to look at them kind of quickly. Again, the first one looks a lot like the problems we've already been working with. We're going to subtract our 50 as negative 27. Then we're going to divide by 3. We've given us a negative 9. And now we take that square root, just like we thought we needed to. Now, this one's a little bit tricky. Don't forget that the square root of a negative number is not real. There's no number that times itself would have given you negative 9. So the square root of negative 9 is a not real answer or no real solution. And that's your final answer there. There's no number that you could ever square times 3 and add 50. The numbers are only going to stay positive and get bigger, and yet end up at 23. It's just not going to happen. On the right side, as I said, do not FOIL. I know it's tempting, but the idea here is if I divide away the 2, the last thing, or first thing happening would have been subtraction, right? If I take one of my answers, let's say I grab this 6 right now and I go to check my answer, it would have been 6 minus 3. 3 then would have been squared to make 9. Then we would have multiplied to get that 18. So the idea is I'm going to go backwards. I'm going to get rid of the 2 first. I'm going to divide by 2. Now let's get rid of the squared because it's outside of the quantity. We can just say the square root of the whole thing. Square root of something squared cancels away. We just get that x minus 3 left over. On the other side, the square root of 9 is 3, and don't forget the plus or minus. And now it gets a little bit tricky because we still have a step to go. So now I need to take positive 3 and add 3 onto it, right? I'm going to take this minus 3, I'm going to subtract 3. So I got to add 3 on both sides. So on this side, again, they're going to cancel away. Right? So this cancels here. But again, this plus 3 then that I'm putting on the other side, positive 3 plus 3 is going to be 6. And negative 3 plus 3 is going to be 0. I have to sort of split my answer into 2 parts. Because again, I've got that plus or minus. Positive 3 is over here. And that negative is right here. Don't forget to do that at the very end. Get those 2 answers. All right, that's kind of a tricky one, so you might want to take a second look at that. But I think it's definitely doable. But don't be afraid to rewind and kind of walk back through that again one more time. Now, moving forward, though, we can use quadratics or solve quadratics in lots of different ways, use them in the real world in lots of different ways. One of those is the falling object model, or falling motion model, sometimes we call it. And we've worked with this before. The final, or the height of an object at any given time t is given by gravity pulling that object down, negative 16 t squared, plus its initial height. Again, just a falling motion model. We're not throwing the object in the air. There's no initial velocity. There's no middle term there. So the idea is a basketball is going to be dropped from 56 feet. Well, that means that 56 feet, that's our S value here. So basically we can say, well, what will be, how long is it going to take, find t, when it reaches the ground? Well, its final height will be 0. Negative 16 times t squared. And again, we're starting at 56 feet high. Now, one way to do that is just to estimate, to start plugging in numbers and say, okay, well, if I plug 1 in, I get 40. If I plug 2 in, I get negative 8. If I plug in all the numbers in between those 2 numbers in, right, I can get a whole bunch of other values. There we go. And I know that 0, again, falls somewhere in between these. And I can keep approximating that decimal, somewhere between 1.8 and 1.9, and I'll find my answer. A better way, though, much faster than estimating, is, again, just solve. If I take negative 56, put it on the other side, then I divide by negative 16. Right? T squared will end up equal to, and with a little bit of magic, again, dividing by that 16, we'd have 56 over 16. Take the square root. Now, I'm not going to say plus or minus this time, only because we can't have negative time. But we end up with positive 1.871 seconds. I hope that helps you solve with square roots. Good luck and have fun.